Assalamualaikum and greetings to all. We are going to talk about optimization problem. But before we start with our question, we need to know what is optimization problem. Optimization problem is the problem of finding the best solution from all feasible solutions by maximizing desired factors and minimizing undesired ones. This can mean a variety of things, from deciding on the most effective allocation of available resources, to producing a design with the best characteristics, to choosing control variables that will cause a system to behave as desired. Optimization is also useful when there are limits or constraints on the resources involved or boundaries restricting the possible solutions. Optimization is a part of life. If we look at the nature, we will see optimization everywhere. There are few guidelines for solving maximum or minimum problems. The first step is read each problem slowly and carefully. Do not misread the problem or hurry through it. The second step is draw a sketch or diagram of the problem to be solved. It helps you in organizing and sorting out your thoughts. The third one is define variables to be used and carefully label your picture or diagram with these variables. The fourth one is write down all equations which are related to your problem. The fifth step is before differentiating, make sure that the optimization equation is a function of only one variable. Then differentiate using the well-known rules of differentiation. The last one is verify that your result is a maximum or minimum value using the first or second derivative test for extrema. So we move on to our question. In a beehive, each cell is a regular hexagonal prism open at one end with a trihedral angle at the other end. It is believed that bees form their cells in such a way as to minimize the surface area for a given volume, thus using the least amount of wax in cell construction. Examination of these cells has shown that the measure of the apex angle theta is amazingly consistent. Based on the geometry of the cell, it can be shown that the surface area S is given by 6sh minus 3 over 2s squared cotangent theta plus 3s squared square root 3 over 2 cosecant theta, where S is the length of the sides of the hexagon and H is the height of constant. A. Calculate ds over d theta. B. What angle should the bees prefer? C. Determine the minimum surface area of the cell in terms of S and H. For part A, the question asks to calculate the differentiation of surface area S. Since the equation of S is given by the equation, which is 6sh minus 3 over 2s squared cotangent theta plus 3s squared square root 3 over 2 cosecant theta. So we just need to differentiate from this equation. But then the question said that the H is the constant. So we do not need to differentiate this part. So the ds over d theta is negative 3 over 2s squared, and the differentiation for cotangent theta is negative 3 cosecant squared theta plus 3s squared square root 3 over 2, and the differentiation for cosecant theta is negative cosecant theta cotangent. So the answer will be 3 over 2 s squared cosecant theta bracket cosecant theta minus square root 3 cotangent theta. So this is the differentiation of the surface area S.
Next, for part B, we need to calculate the angle what should the bees prefer. So we just need to equate the ds over d theta equals to 0. So 3 over 2 s squared cosecant theta bracket cosecant theta minus square root 3 cotangent theta equals to 0. So we just need to bring 3 over 2 s squared cosecant theta to the right hand side, and when it divided by 0, so it will equals to 0. So we will left cosecant theta minus square root 3 cot tangent theta equals to 0. Cosecant theta equals to 1 over sine theta minus square root 3 cos theta over sine theta equals to 0. Next, the equation will be 1 minus square root 3 cos theta over sine theta, since that the denominator for the both equals to sine theta. Then we just need to solve the cos theta, which is 1 minus square root 3 cos theta equals to 0. Cos theta equals to 1 over square root 3. Theta, it will be equals to cos inverse 1 square root 3, and then the answer for theta will be 55 degrees.
So I'll continue with the C. It asks us to determine the minimum surface area of the cell in terms of S and H. So from the previous question, the part B1, we know that the cos theta equals to 1 over square root 3. So we only have to find sin theta. So how to find the sin theta? We use the trigonometric identities, which is sin theta equals to square root 1 minus cos squared theta. So from here, we just only have to substitute the value of the cos theta here. So it will be 1 minus 1 over square root 3 squared. So from here, the answer for the sin theta is square root 2 over 3. So this is the value for sin theta. So next, we use the equation of the surface area, which is this one, and we substitute the equation, the value for both cos theta and sin theta into this equation. Okay. S is equal to 6sh minus 3 over 2s squared cot theta plus 3s 3 over 2 cosecant theta. So from here, the cot theta and cosecant theta, we know that it is equals to cos over sine, and this one is 1 over sine. So we substitute it. 6sh equals to 3 over 2s squared cos theta equals to sine theta plus 3s 3 over 2 1 over sine theta. So now we have this equation. So from this equation, we just have to substitute all the value here. So we substitute the value here as squared 1 over plus 3s squared 3 over 2 and 1 over 3. So from here, we get the equation 3 over 2 s squared times 1 over square root 2 plus 9s squared over 2 square root 2. So we only have to complete the equation, and we get the equation. The last answer is 6sh plus 3s squared over 2 square root 2. So this is the answer for the last question. Thank you.